I think we've got there. That looks to me like a burnt out, it is a burnt out piece of track. So we'll need to link a wire across that, and that's between the on and off switch, and that will be because of that short circuit on the power transistor. So I'm glad I found the power transistor problem before I found this piece of wire print linked out. Or burnt out, shall I say. Let's turn the power off. He's been sold a right pop here, as we would say in Yorkshire. No, I haven't quite got the insulation off that. So we'll go to that point there. And hopefully it will now power up. Okay, so we've got it now powering from the far side of the choke, the near side of the choke, from that pad, but not from that pad. So it looks to me like the power input choke is somehow burnt out, which I find a bit bizarre. These are quite hefty coils. Anyway, we'll look into it. Okay, and we're now rewarded with power. So we'll start with putting the signal generator on and seeing whether it receives, or whether the synthesizer's altered because of what's happened to it. Well, he's receiving, but it's very, very deaf. So that's good. That's a good sign because it is receiving. So is it transmitting? It is. It's doing 3.9 watts. And I think that is the power control. It is. And we'll just see if it's on frequency, and that's something we can deal with. Oh, it's on channel... Oh, no wonder it's not receiving, right? It's on channel 19, and I'm on channel 20. And there's the delivery from RS. Okay, so it was RS, so let's see what they have brought. Hopefully it is some replacement solder suckers. And it's some replacement solder suckers, so that's handy. So So the one we borrowed off Mr. Chippy, that's his backup one. So I'll hold the end, press the button, and it's got some good suction. Good. Right, we'll get this tuned up. Switch the power on. And right now, we're going to have to plug the test equipment in because it's coming through the speaker mic. And that isn't the right plug. So does this socket work? Yes, it does. So just see what the cyanide is right now. So for 12 decibel, it's not very good at all. I'll just show you what we're looking at. Not that one. So we've got 12 decibels on there. You can see that's more or less on the 12. And if we look at the attenuator controls, we've got the big hand on 3, we've got the small one on 1.6. So it's actually doing 1.8 microvolts for 12 decibel cyanide. Now, of course, this crystal filter may be totally wrong. That could be the big cock up here. So I'm going to make a... I don't like to write on manuals, but this page is useless. So it's 1.2... No, it's not. It's 1.5, 6, 7, 8, 1.8 microvolts for 12 dB. So we'll come to that. It's doing 4 watts, and let's see if it's on frequency. We're going to go through... In fact, I'll tell you what, we'll go through the transmitter first anyway. So we'll go back to meter there, key up, we've got RF breakthrough coming through the test set. We don't usually get that. It's a bit high, the frequency, but that's fair enough. So that's maximum. Maximum. That's a bit better. That's not really the right tool. That seems to be broken. No, it's not. My goodness, that's needs to come down. Okay, so that's doing a nice 4 watts. So we'll look at deviation. Oh no, we'll look at whether it's on frequency. So let's put the camera over to there. Just needs to come down a fraction. 277913. So I mean, this is neither here nor there. That's a spot on his. Are we going to get it down a bit? We'll bring it to there. 277912 twaddling toggling between 6 and 7, which is fine. Deviation, wow, it's 3.5. What's that about? Let's try it there. Wallow, 1, 2. That's it. Exactly right. Now these are a loudspeaker which reverses as a microphone. It's not the ideal way to do it. So in there's a transformer to change its impedance from low to high. So expensive way to do it, not an ideal way to do it. Would have been cheaper to put a electret in there, but there you go. I'm not the manufacturer. Perhaps they've got millions of transformers left from the American AM days. So I'm happy that's transmitting on frequency. I think we will look at this one on the spectrum analyzer. I'll put that on ready. That's going to be the trap for 100 and sorry, for the third harmonic, or the second harmonic. It'll be the second harmonic, won't it? 50 something megs. That'll be the trap for that, I am sure. And I don't think they've ever messed with that, and that's very sensible. So receive. So we've got to get this, stop this from being as deaf as a post. So let's go over to the cyanide meter once. Oh, we'll do the detector first. That's the answer. So put an S9 equivalent signal on there. Just turn the volume so we get the right kind of waveform. Pop the bench light off. It's a bit distorted. I'm going to sneeze. So let's see if we can pop the detector. Oh my goodness, it's absolutely miles out. And we may be able to just get rid of the nastiness with that coil. We'll come back to that. So put the bench light back on, we'll go over to the cyanide meter. So this would have been pretty distorted with and quiet. You'd have a lot of background noise and not much voice with the detector being as far out as that. So we'll just about hear it there. So let's see whether we can bring that in a bit. No. It'll be the crystal filter which is wrong. We can't send this out like this. So we've now got it to 1.5 microvolts. So the way they've done this, the impedance will be wrong. So we're just going to restore it back to factory original and get rid of the crystal filter. That's far too deaf. Oh yes, I've got rid of your bleed over, mate, but I've got rid of it because it's now deaf. And that isn't untypical. So we'll pause the video. Okay, so we've taken the crystal filter out. I don't know anything about crystal filters. We don't do these kind of modifications that end up having to be undone. But just for your information, it's a 10M15AA, 10M15AA, and it's clearly of Uniden manufacture. So, what they've also done is taken out resistor 189, 390 ohms. So I've spotted a gap there. So we've got the replacement filter in, and we'll pop in a nice new resistor. And I'll show you where that is on the circuit in a moment. So this is going to have to not be finished today because we haven't got any 5 picofarad capacitors and one's missing down there. I thought I cleared all the holes, but obviously not. supposed to be 1/16 of a watt resistor. It's 0.6 watt, which I'm putting in, but it's not that much bigger. So we'll cut that lead. The other one, because the track's been damaged, we're going to have to, I think we'll lay that across to there. Hopefully that'll solder to the filter, and that will solder to its track. So hopefully we're there. So we'll power it back up and we'll see whether we've actually got any improvement, or whether I've got to look for other things that have happened to the radio, or whether it's deaf for another reason. Wow, it is. So I've not moved the equipment. It's straight away it's come up. So I have not moved that, and we're now at something like 18 decibels, Synod. So let's see whether we can go down a scale. We can. It still isn't fantastic, but it's actually doing 1 microvolt. So that's fair enough. So we'll just retune it, because the filter will have changed where the tuning point is. Seems that's on a false tuning point. It's in a funny position on the coil. Nope. Okay, so what we got? Just under 1 microvolt. Well, considering what's happened to this radio, that's remarkable. I'd like it to be 0.6, but it isn't. We've had these before, which have been 1.2, so this is the trouble. You're going to simply changing that filter as, what was it, 3 point, I wrote it down, didn't I? 1.8 microvolts, and we're down to 1 microvolt. So it goes from being unusable in my book to being usable. That's the difference. I can't see any of the components changed around there, and that is fair enough, as I say. Now we can't finish the set because of that. So let's look at the meter. So 100 microvolts on the radio, and we should have all 4 bars kind of lit up. I say kind of because it's a bit arbitrary as to what they actually mean. So the S meter is the preset there. Helps if I use the correct tool. Okay, am I on the wrong one? Is it that one? Oh, well, I'm really stuck here. Right, we'll do it the other way around. We're going to transmit. And I thought that back one was the RF meter. No, I'll reduce the signal and see which one of these makes an effect. It is that one. It is that one. I wonder if it's dirty. It's not having any effect. Well, we'll look at the squelch anyway. We'll skip around them. So, squelch on full. And I want the signals generator, when I put it to 100 microvolts, I want it to open up the squelch. 1, 3, 10, 30, 100. It's exactly where I want it to be. That's spot on. The preset for the squelch is just down there. So that's the deviation. The squelch is just down there. We don't need to touch it. Now we'll check the sensitivity at the other end of the scale. So I'll turn the squelch right down, set threshold. The signal generator is on standby, and I've parked it at 0.3 of a microvolt. Switch it back on, and let's see when it comes in. And the answer comes in at 1 microvolt, and it leaves off at 0.25 of a microvolt. So, out of interest, how far down can we hear the signal generator? So it may be doing 1 microvolt for the 12 decibel sinad, but how far can we actually hear it? So I'm going to turn it to 0.3. We can just hear 0.3. You can hear down to 0.25. I'm going to recheck the detector just in case that filter has changed the way the detector was set. And you know what? I'll just go back to that. Do you remember it was distorted? It isn't distorted now, it's perfect. So it was the crystal filter which was doing that. There we go. So let's see whether we can set up the S meter. Nope, we can't. I'm going to turn the power off. We'll have a look underneath the set. I wonder if it's been shorted out. It may be a Duff preset. There's something missing there. No, they've just drilled an extra hole. That's fine. So what what I do have to do behind the scenes is put the low power switch in and the missing wiring. So that's something I'll do. We're not going to get that 5 picofarad capacitor till Monday, and that's going to put in a spanner in our works because I don't like to move things off the bench. But on the other hand, I don't want to not do anything. The other things to do, that's going to have to be spliced back into the pack, isn't it? Not the best fit either, and that's what do I do with that socket? You know, where am I going to get another one of those? So I don't know. I think we'll research what if we can get another of those, because it'd be nice to change it with it being in the state it's in. Can I find any switches? sockets. Jack power. At least it says 2.1, so we do know it's 2.1 millimeter. So there's a nice giveaway. So DC plug and DC jack. So I'll see whether an MJ179 exists. So the next problem we've got, well, one of many problems we've got, I'm waiting for parts. So it's now Saturday, so this isn't going to get any parts till Monday. We've got a socket on order, believe it or not. I put in the part number from the parts list and they still make them. Nothing to do with Midland or anything, it's a part which is bought in. And so that's fantastic news. So that's, our wholesaler was out of stock and they were something like 50 pence, and I've had to pay for, I think, $2.79 off eBay for one delivered. So not as cheap for the customer, but there you go. At least it's going to, as you can see, it's waggling around. I'm just using the crocodile clip because it's not reliable enough to use as the power connector. So the dilemma we've got is, I'm expecting he's wanting to use this with the aerial if he's got the aerial, or get an aerial. But the loading coil's missing, as we know. The loading coil should be there. So if we look at my set, the loading coil is there. So when I look at these scrap ones, which are slightly different model, the D version instead of the UK version, that's where the loading coil will be, and on both these scrap chassis it's missing. I don't know why that is. I mean, I just buy these, you know, that's how it is, £2 each. So what we're going to do, we're going to make one, because we haven't got any alternative. So I think we'll undo the aerial connector so we're not straining that. I think we'll undo the microphone so we're not straining that, so we just have the body of the radio. So what we're going to do, we don't know whether my set works, but when I've done that one, I'm going to do mine off camera, of course. You don't want to see two one after the other. I'm going to unsolder that right now. We're going to make another one the same. You know, what else can I do? So, with the appropriate glasses on, and guessing where it is, that's cleared properly, so we'll just push the wires down with the soldering iron. Hopefully we can remove that without any damage whatsoever. That'll be fun putting back in, with it being inherently springy. So we have 1, 2, 3, 4, 5, 6 turns. If I can find my impedance meter without bashing the microphones, so we've got 0.14 microhenries. So to make this, we're going to use a twist drill former as a former, and I've been over to our church pipe organ workshop, and I've got the wire gauge, and I'm in standard wire gauge, I'm not in metric. what's this going to be, 18, a bit smaller, so it goes through there. It's a bit difficult because it's been soldered. I don't want to get the thicker wire by mistake. It's 19. So I've got that as 19 standard wire gauge. That's going through easily, and it's not going to go through 20 at all. So I'm going to have a look round for a reel of 19 SWG wire. Huh. It'll look well if I have to order it in and spend 10 quid on it. Just before I went to stores department, and that kind of stuff's a shed outside, I found this scrap Uniden. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. And look at that. I reckon that's the same gauge and the same diameter. I'm not going to unsolder that. We could remove one turn. That could save me some bother. Oh, I tell a lie, it's an audio line. That's actually 20 gauge and not 19. But let's see what it reads on here. It's the right diameter, but it's 1 gauge lower. So it's 0.3. One, two, three, 4, 5, 6. Just unwrap it using that tool, and I hope not to damage it. Leave that a little bit longer. Just scrape the insulation. So see what it reads with the turn removed. Oh. Well, actually getting the same reading now. I don't know what I got before, whether I was touching it or something. So it got, I mean, it's going to vary, isn't it, depending what you, whether you stretch it or what you do with it. So do you know what we're going to do? We're going to put the homemade inductor in my radio. And we're going to put the perfect one out of my radio in the customer's radio. So there we've got the pretend one in my radio, and all we now need to do is to get the real one in the customer's radio. Just making sure it fits from that side. Right then folks, it's now Monday and we started this job on Friday. And you know, it's company policy not to take jobs off the bench. So I've got this clogged up with, this bench is clogged up with this radio. And Mr. Chippy's bench is clogged up with something else. Which one's the one? Which one's the customer's? It's the one with the capacitor missing. Yeah, it's that one. So we've had a delivery from RS. Royal Mail has just brought it. Order number 805 UK. Well, I reckon if it's order number 805 UK, of course I had to buy 10 of them, didn't I? You know, I only want one, but and they're not cheap. They're 60 pence each or something like that. These are 1000-volt ones. You know, he's not going to have problems with it burning out or anything. The trouble with RF Energy, hey, made in the Czech Republic. What about that? And I've no doubt that some clever people out there will have some formulas how many volts you need to do 4 watts. But seeing as 5 picofarads was only offered, I wonder what my meter makes of it. We don't normally use the impedance meter for testing capacitors. I'll just be interested. 8 puff, right. Good thing with a new component with long leads is we can actually insert it into the board without as much struggle as when it's a shortened one. Okay, well we finally managed to. Can you say manhandle any these days, or is it person handle, or manipulate it into position? That sounds frightfully posh. One manipulated it into position. Okay, so we're just waiting for that connector to come via eBay. So that's the end of Monday. When will that come? Tuesday? Wednesday? Will this have been on the bench a whole week? You'll all think I've died, won't you? You'd be cheering if I did. Okay, every missing part's now being put back in. Diode down there. The wiring to the high-low power switch. The replacement power connector. And we will plug this into the test instruments. We'll just finish off that alignment, because if you remember, we couldn't do low power because there was no high-low power switch, and we couldn't align the RF output meter because you actually need to do it on low power. So here goes. Let's plug the mic in. Yep. So we'll go to picture-in-picture, key up, so we've got straight away from 4 watts in high power and nothing in low power. Okay. Just make sure it's the right way round. So what have we missed? Oh yeah. Forgot to solder that to that. That's better. So we're on the low. We'll switch on the low scale, and there's 400 milliwatts. So we've got low power back. So with the on low power, let's see what that meter's reading on the front. It's reading 2. It needs to read 1. So where did I put my notes? That's an envelope. That's as low as we can get it. So on high power it's going to be all 4, on low power it's 2, it should be 1. So your S meter, I think that was out of kilter a long way as well. Let's see whether we can make that any better. So just put the frequency in on the frequency counter, on the signal generator. That should be S9, and that should be less. Well, it is. So let's just turn that down. Just while I'm at it, I unsoldered that slightly. Well, I don't seem to get any difference on here. So is the preset broken? We've got one on a scrap chassis. Not like that. So RV102. We'll have to get the service information back. So, it's supposed to be 10k. Well, it is 10k. So just check there's no short circuit making it light up when there's no preset present, which there isn't. Well, I'm not exactly bothered about this. It's so unimportant. Okay, well, it doesn't adjust. Right, well, that's so unimportant. It's reading a bit sensitive. But the final thing is, this isn't screwed to anything anymore. So if there's a nut and bolt, we're going to have to do something. So normally it's screwed in like that, but on this one that's been drilled out, so they've put that daft heatsink on. Now on this one you've got a second hole, but on that one you haven't. Now we could drill out that second hole and make that the one and only fixing hole. If only we got a countersunk screw we could use. Right, so what we'll do, I've had an idea. We'll drill out this second hole. I've checked the drill bit size against the other set. Ah, the hole was there all along. It's just because the heatsink's shifted slightly. We're going to pinch the screw out to the other side, because there's already one there. There we go. Solved it. So that's on one screw instead of two, and that is on both screws. End of problem. We're done. It's doing low power. It's doing high power. Right, we'll put the lids back on. I mean, this I'm obviously going to be losing hand over fist over this. I'm doing this to help somebody, but I mean, at the end of the day, these radios will always fetch 60 odd pounds second hand, won't they? So it's not like they have no value. But for somebody to turn a nice radio into a experimental piece of junk, it's ridiculous. But that's what people do. I'm not in the car game, you know. Obviously we have cars, and I know what our requirements are, and I know what's on the market, and I know what makes we want. and so on. But I don't get people who mess about with cars and turn them into something they never were. And I remember back in the days of the Ford Cortinas, which were one of the British built, certainly in the lower range, and this is before the days of electric windows, and you could buy from places like Halfords, you could buy adding a kit to add electric windows onto a car with manual windows, and you put this huge box inside of instead of the window winder and connected it up. You got these ridiculous huge boxes on each door, and you know, people would come to sell their Ford Cortina, and it's got electric windows. Well, yeah, but it didn't enhance the value, did it? Dear. Right, we're there. So we've got it's receiving 791. It's transmitting. It's Warlow. Where's deviation then? All I'm getting is a leather rustle. Warlow. Warlow. Is that because I'm getting feedback from the speaker? Warlow, probably. So what we'll now do is we'll put it on the aerial. I'll just listen to the audio on low power before we actually do 19 for a Roger. I'm not sure what that wire was they'd taken out of the mic, which I had to put back into the socket. So just get our little Pt2 portable. Testing 1 2, testing 1 2. Wow. Here it is, more or less back together. 19 Roger. Helps if we're on the high power setting. 19 Roger. Okay, well there we are. So hopefully we'll do an on-the-air test, and that can then go back to the customer. What a marathon job, and what a shame, because it's also unnecessary when people have messed around like that. Thank you for watching the Midland 77805 UK.